Very excited to introduce this new session, which is episode 2 of Hangout and Nerdout, our joint production with Make. So my hosts Jinger and David will be on in a second here, and we're going to introduce our 3 guests, 3 hosts, 3 guests, 10 minutes per guest. They get to give a little talk about what they're up to, and then we're going to have 15 minutes of a panel Q&A where you can ask them questions, we can ask them questions, they can ask each other questions. If you have questions, put them in the Q&A down below. And then after that, we're going to have a moment where everyone can kind of join and ask your own questions in a sort of a free discussion period. Yeah, David, tell us about yourself.
Alrighty, I'm David Groom. I am sometimes known online as iShotJR. I am the community editor at Make. I write articles like for our upcoming 2022 boards guide. This is a 2021 version. And edit other people's articles and manage other contributors. And I participate in and organize events like this, live streams and things like that. And yeah, I think that's about it.
Cool. I can go next. I'm Alex Glow. I am mostly the video host and hardware nerd at Hackster.io. I'm not the only hardware nerd, especially anymore with Jinger here, but I do put that on my business cards, and it's what I do is I make weird projects, including companion bots and PCBs and things like that, and teach people about new technology that's coming out at Hackster.io/videos, and run a weekly Hackster Cafe session where at 10 a.m. Pacific every Tuesday, we talk to a guest nerd for a longer session, about an hour, about whatever they're working on. And I'm really excited to be here doing Hangout and Nerdout, a new monthly session where we have 3 nerds. All right.
And hi, everyone. My name is Jinger. I am the contest manager at Hackster. So I'm super excited. You know, we have so many new initiatives. You know, this year, this Hangout and Nerdout is a collaboration between us and Make. And, you know, this is a second episode that we're doing. So it's still kind of like a new format, and we really wanted to create a container, a space for the community nerds to come out and just hang out and nerd out with us. Really, the name says it all, and super glad to be here and introducing our second round of nerds that's going to be talking about sustainability, about impact. Hackster, you know, it has been a home for open source projects, you know, for all these years and different nerds. So that this is really just our way, another way for us to interact with the community.
Cool. And we have a couple little quick calls to action before we get started and bring our panelists in. Would you guys like to take that away?
Yeah, so for those of you who just joined the event, joined the Impact Summit, who are not super familiar with Hackster yet, let me just walk you through really quickly what Hackster is, and then David will also introduce, you know, what Make is. Are we able to see my screen here? Yes.
That's great.
Yeah, awesome. So Hackster, we have 10,000 of different open source projects. You know, on the page on the website itself, we just surpassed 2 million users this year. So so it's really amazing. You'll see like anything, you know, from beginner level to super advanced level type of project tutorials on our site. And then so overall, like you can look at projects. The different channels will allow you to go into different community hubs or different platform hubs that's organized by either company or like a local community. The Hackster News is a kind of on-stream industry trend feed that also, you know, it's our curated content written by our writers that to keep you up to date with all the tech news. This is my favorite page because I run the contest, and we have many exciting contests that's going on all the time where we partner with companies, with hardware companies, in giving out giving out awards, you know, to the best to the best projects and on ideas that's related to certain technology. Those are really fun, usually a couple months long. Right now we have like drones contest, and then also today in our Impact Summit, we'll be doing winner announcement for our IoT Into the Wild contest for Sustainable Planet contest that's co-organized with Seed. So just check out like the contest page, and of course like all the different videos that's amazing, created by Alex, different unboxing and different tech highlights. So it's really a great resource for anyone who's interested in tech, in learning about new technology, or joining a global community of developers and nerds.
Oh yeah, look at that.
This is our most recent issue. We're all MacGyvers now. And then the next one coming next month will be the 2022 version of our boards guide. This is the 2021 version, which comes with a handy pull-out guide to boards that features 79 boards that we think are good for your next Make project.
Man, I wanted to make something like that for so long, and it makes me really happy that y'all are just doing it. When I saw your first one, I was like, oh, it's the thing. It's like, it's manifested in the world. Okay, cool. Let's bring on our guests. Olya Irzak is the CEO of Frost Methane, which is a company doing some really cool stuff. They install highly efficient flares to destroy concentrated sources of methane, turning waste greenhouse gases into value for landowners. Frost Methane exists to identify, monitor, and flare concentrated methane seeps from active and abandoned coal mines, Arctic permafrost, hence the name, and other geologic sources worldwide. The project is building a global network of self-sustaining devices to reduce methane emissions, which is many times more effective as a greenhouse gas than CO2, I've learned from the materials put out by Frost Methane. So Olya is also the co-founder of the Diamond List, a curated annual list of early stage and game-changing climate companies recommended by top climate investors. So exciting. She is passionate about emission reduction technologies in the grid, agriculture, transportation, non-electrified industrial processes, natural emissions, etc. Please take it away with your presentation.
Thanks, Alex. I'm actually going to do the CEO thing and present some slides. I hope that's okay. Thanks so much for the intro. Super fun to be here. As you can tell, I'm a giant climate nerd, but also fantastic. Can you see my screen now?
Looks beautiful.
Yes.
Fantastic. All right, let's full screen that. Okay, so real quick, here's this absolutely crazy thing that we do, and I'm actually gonna talk a little bit about this company like 3 years ago, a little bit more than now, because origin stories are super fun, and I think it's kind of the hacky part of like really fast iteration that I think would be the most fun for this crowd. So here's how this whole thing started. In Siberia in like 2014, these like weird holes started popping up, right? And as far as we know, like there was these big explosions, charred pieces of permafrost everywhere. And folks are like, that's really interesting. Why is there, this was attributed to methane. Why is there such concentrated sources of methane that are coming out? And so it's literally the fault, like this company is created because of the Siberian Times, but that's not something people say very often, because of this particular article that said, hey, in this like one peninsula in Siberia, there's this like giant amount of these hills that are ready to release a lot of methane, right? And so I did it back at the envelope. It looked like about 0.5% of total global emissions from this one peninsula. And I'm like, sort of feel like we should try to do something about this. We didn't end up tackling this first. We were tackling these bubbling lakes in the permafrost. That was our first installation. But regardless, the important piece here is, as Alex mentioned, methane is a really, really potent greenhouse gas, so much more potent than CO2. So if you, for example, turn a molecule of methane into a molecule of CO2, big win. And much like CO2, it has increased in the atmosphere since pre-industrial times. It also has some negative health effects through a complicated ozone, ground level ozone creation process. So all around, don't want it in the atmosphere. Okay, so what we do is we fund everything through carbon offset markets, right? So carbon offsets, like the turning a potent greenhouse gas into a non-potent greenhouse gas. We identify these high impact sites, sometimes in the permafrost, sometimes abandoned coal mines. Manure ponds, for example, produce a lot of methane. So there's a wide variety of sources that are not, that have like no regulations around them, right? Like sometimes even the ownership isn't clear. We've built devices. There's generally a piece that is relevant to all sources, and usually the collection part is a little bit different per source. And then we go through a process, including auditing, in order to issue these carbon offsets to generate money that will allow us to build and design and install all of these things. So here are some example sources. You know, here is on the left is a methane source that you can just like literally light on fire. It's that concentrated. On the right, this is an Arctic lake that is completely bubbling with methane. On the top is an old pipe from an abandoned coal mine. And so if you kind of add all of these sources together, and this is a pretty conservative estimate, we found just on the coal mine side, we found 1.1 gigatons of CO2 from less than 3,000 sources that are currently entirely unaddressed. If you don't think in gigatons, let's say we managed to mitigate like half of that, which would be, you know, extreme success scenario. It's something like taking half of the cars in the US off the road, right? So that's like just an idea of like how potent methane is. Okay, so then we go and install. So here's our installation in the Arctic. On the right top, we are roasting marshmallows off of that flare. And you can kind of see that it was a really surreal experience, kind of bottom left. This is long before we formed the company. We were just like messing around with this. You can kind of see this big flame coming out of the gas that we're trapping off of an lake north of the Arctic Circle. Super trippy experience. So lots of fun design challenges, right? So here's like an old photo of the device. You know, the huge temperature variations, right? Inconsistent gas flow because these bubbles are not like, it's not the Nord Stream leak, right? Which is a large, steady thing. I'm still upset they didn't set it on fire. This is like much more highly bubbling situation, inconsistent flow. You can't, there's no roads, right? Like you need to be able to carry anything you're bringing in there, including your ballast. There's no power supply. You can do some solar, you can do some thermoelectric, but there's limits to both of these. And the bubbling actually has very large lifting forces. The water level changes, so you need crazy anchoring systems. So these are all the things that my absolutely brilliant team solved. I'm a software engineer. I take zero credit for all the mechanical and electrical brilliance that went into that, but I am fluent enough that I can definitely answer details in the Q&A if that's of interest. You know, and then of course the electrical and control, lots of sensing. Of course, you need to have communication through satellites to know whether your device needs maintenance or is broken or something went wrong. Relighting in case anything goes out. There is basically like the electronics are extremely energy efficient in order to be able to last a long time in these like crazy situations. Not very many batteries, by the way, work in those conditions as well. So battery selection turned out to be a thing. Here's some fun trying to trap some of that gas. Anyways, but the takeaways that I really want to talk about is pick a problem that you care about. It's just so much more fun to be pushing on something where the outcome matters. Getting into the field as soon as possible was a huge lesson for us. The conditions that we have are not ones that we can replicate in the lab really well. We definitely bubbled some air through the bay in San Francisco in order to try to like trap the gas off of like the back of a friend's boat. So we did as much as we possibly could, as cheaply as we could. This was all being done on my bank account at first. But that iteration of just like getting out there and, you know, you're gonna fail in environmental conditions. You're gonna fail on things that you haven't thought about more than on things you have thought about, even if your team is absolutely spectacular. And so getting out there and iterating is like almost the only thing that matters. The other thing is, the other learnings from the past few years is you can build the coolest, best tech, but if you don't have a really good plan for how it gets out there, and if you don't have really good business people to help you get it out there, the impact might be less. And I'm like super impact driven. I wasn't always impact driven. Sometimes I was just very super cool tech driven. So depending what's important to you, whether that matters or not. But, you know, in our case, the tech is always ahead of the business because we're sort of all come from the tech world first. The team is absolutely everything, right? There are some projects that are small enough to do by yourself, but for things of that magnitude, there's just enough different skill sets. So pick people you love working with and that you really respect. And, you know, for me, like really this business was built off of amazing people. Like everybody on the team is smarter and cooler than me. It's fantastic. And then, you know, if it's not fun, then there's always a question of like, why are you doing it? There's bits that are not going to be fun, but overall, that's always kind of the best of that, if you can do that. So yeah, that's all I got. Definitely excited to do the Q&A afterwards.
Yeah, I think we actually have time for one really quick question. You got a couple minutes left. So someone asks, if someone's smoking a cigarette on a boat, would that cause an issue?
Depends on the flow rates. So essentially in the situation that you were seeing, those bubbles, like methane dissipates in the air reasonably quickly. So let's say the Nord Stream leak that was happening a couple of weeks ago, if you're on top of that, you're like the engine of your boat is gonna set the entire thing on fire. So you definitely don't want to be smoking over there. In the situation of where we were, you wouldn't be able to really sustain a flame without trying to engineer sustaining a flame. So you might get like a big poof, but it wouldn't be anything. That the particular site that I showed with the bubbles, not severe enough to do that. Those big holes in Siberia, maybe, right? There are some places inside there that are consistently flammable. The place, some of the other sites that we showed you would definitely light things on fire if someone's smoking a cigarette there.
Wow.
So depends.
Oh, thank you so much, Olya. Let's move on to our next speaker, and then we'll do the Q&A as a panel afterwards. Well, after the next two speakers.
Yeah, and next on is Álvaro Prieto, and he is a electrical and firmware engineer who loves cheese. And Álvaro has been on our Hackster Cafe as a guest before. We're so excited to have him back, you know, to nerd out with us. As the principal embedded software engineer of So Far Ocean Technologies, he will be discussing how his network of ocean buoys delivers real-time ocean intelligence to collect, network, and distribute vast amount of ocean data, and then combined with vessel performance dynamics to achieve voyage, hence help logistic companies to meet emission reduction objectives. And we're super excited to bring this ocean tech, you know, to this series. So take it away, Alberto.
Hi, thanks. Thanks for the intro. Yeah. So my name's Álvaro. I'm an engineer at So Far Ocean. I've been working on buoys now for over 2 years. And here, just because it's I'm in the office right now, this is one of our buoys, and these kind of drift all over the ocean, and they are used to measure waves, winds, temperatures, pressures, and other things, and report it back over satellite to kind of our cloud, and then we use that for all sorts of stuff, right? We've been undersampling ocean data forever, basically. So we're trying to, you know, start measuring things again and use them. I'm in the firmware team, so I work on the actual guts of the buoy. So this is something that lives inside, and it has the brains, the battery, all that stuff. And some of our customers will buy these buoys and put them in a particular location. They'll moor them to the ocean floor and use them to take various kinds of measurements. For example, aqualink.org is one of our customers. They use them for coral reef monitoring. So we'll have these buoys, and then underneath the buoy, we'll actually, this one's a temperature sensor, but it could also have a cable that goes all the way down. And then in that cable, we have sensors along the way, and they actually use those to measure the temperatures at various depths and monitor coral bleaching events and that kind of thing. So that's one of our uses. Jinger mentioned one of the other ones is ship routing. So we measure waves and winds all over the ocean, and then we use that to do weather forecasting. So we have the best wave forecast available out there, and that is used for big old cargo ships. Like if you're shipping your cargo, either bulk or container ships, or containers from let's say Brazil to Singapore or from China to LA, usually they go in the straight line, just shortest path, just go. And we discovered now that because we know how the waves are going to be, what the currents are going to be, we can tell them to kind of go around or slower, faster, all that stuff, and save either, save them a lot of time, which is money, save them fuel, which is reduced emissions, and also just safer voyages. In certain ships, depending on the waves, they might do all sorts of precedent horrible things, and then it can actually be safer if you know what the conditions are going to be like, right? So that's kind of the very very basic of what I'm doing. And let me see if I can share my screen. I didn't prepare anything, but the internet exists. So I'm just going to share some websites with cool pictures. And you can tell me if you can actually see that. This is, are y'all able to see this? Okay, so this is just our homepage, right? But I'll just narrate some of what's going on. These are some of the kind of the dashboard maybe a ship captain would see, and you can see all our buoys all over the ocean. And yeah, every little yellow dot there is one of our buoys. So they're literally all over the world. We also have some, they're being airdropped. Oh, actually, the hurricane that just hit Florida, we were able to airdrop some of these units. Well, actually, the Navy airdropped them from airplanes, but we were able to get measurements of the hurricane as it was happening from the water itself, which is kind of rare. So we have kind of NSF grants sometimes for some of these projects, or different organizations work with us. One of these projects is backyard buoys. So we're working with the NSF as well to get measuring buoys to indigenous communities around the US and hopefully later other places, to bring awareness of what the weather is changing and people need to know. So we're working with folks to do that. Let me see. Oh, this is a cool one. I'll just leave a link wherever I can later, but we were able to track a wave in Mavericks, which is off the coast of California, to a particular typhoon that happened in Japan. And this is only possible, you can see the animation here, due to the network of buoys that we have. So some surfers noticed a really strange wave event that just didn't make sense, and then they reached out, and because they have one of the buoys out there, we were able to track down all that data back to this typhoon, which is really cool. One more thing we're working on is bristlemouth, which is going to be a open standard for underwater communications, for wired communications. So if you have a sensor you want to put underwater, you want to measure whatever it is you want to measure. I don't know, maybe you can measure methane in the water. Maybe that's a thing. And you don't want to develop an entire product to do that. You can just make your sensor, and you'll be able to plug it into this. It's called bristlemouth, or it's going to be called standard. And it's just power ground. And then you do data over the power line. And then it's going to be open standard. And then we can take care of the rest. So you can just develop your sensor, plug it into a pre-made buoy. It'll provide you power and communications back to the rest of the world. But anyway, that's plenty of stuff. This is just what I do for work. At home, I do make cheese, and that's covered in the other Hackster thing that I did. But always happy to talk about that as well.
Awesome. Good, Ginger. Sorry.
Yeah, amazing. This is so cool. So let's actually, Alex, do we have any questions, coming for Álvaro, or shall we move on to?
No questions as yet. I was going to drop. I'm dropping your link for you on Hackster Cafe in the chat here for everybody.
Yeah. So Álvaro, when you do field testing, do you you do go out to the oceans? Does a different ocean have different temperaments?
Oh yeah, I mean, everything's different. But we do locally. I'm in San Francisco, so we do have a little boat, and we go out under the Golden Gate Bridge, and we have deploy some buoys out offshore to test. But most of the buoys we deploy are deployed by some of our customers. So either scientific vessels or just cargo ships. They just throw them out the back as they're crossing the ocean. But yeah, no, every ocean is different. And closer you get to the equator, it's not quite as intense. But if you get close to the south, like to Antarctica, the energy levels are totally different. And now you can actually track, where energy gets put into the ocean and how it spreads around. Another cool thing we captured, we have barometric pressure sensors. When there was that volcano eruption, I think it was last year, and we were able to capture the pressure wave, the atmospheric pressure wave. And there's another blog post about that, but we saw it go around the world a couple times, and our buoys measured that.
Wow.
So this is the air pressure wave, not the actual water wave, because those they're too subtle in the open ocean.
I'm impressed that the air pressure wave was significant enough to measure that way.
Yeah, even my home weather station picked it up. I have one at my dad's house in Mexico, and I picked it up. Yeah, most amateur weather stations picked up that basically a massive explosion that flew around the world.
Wow, that's so cool.
Yeah, in terms of IoT communications, though, like what is the method of actually communications to transmit data?
So these things use Iridium, the Iridium satellite constellation. This new model also has a cellular module. So if you're close to shore, you can just use cellular, and it's a lot cheaper, it's faster. But most of them are just using satellite communications because there's nothing else out there.
Yeah, exactly. Okay, very cool. Well, let's bring on our last nerd.
Yeah.
Awesome. I think Backyard Buoys was a short-lived, eco-friendly boy band in the early 2000s, wasn't it? Anyway, moving on. Raunak Singh is about to set a world record for the youngest Hangout and Nerdout guest ever. So be ready for that. He's also a 9th grader studying in Bergen County Academy's Hackensack at the Academy of Engineering and Design Technology. He's going to be presenting his Hackster project, Monsand, monitoring illegal sand mining. Raunak is skilled in both software and hardware development with an interest in C++, Java, and embedded technologies. He's an advanced violinist and part of his school orchestra. He loves doing gardening with his family, taking care of his pets, and watching and feeding other animals. Take it away, Raunak.
Yeah, so today I'm gonna present my project Monson. I actually started out, if I can just put a screen share, I started out my nerd journey, as I call it, with a COVID-19 detector and many other projects inside and outside of Hackster. And this project that I made, Monson, I submitted into the IoT into the Wild contest with Seed Studio. So illegal sand mining is a huge issue, and many of us don't realize that sand is in almost all of our products, like our iPhones, our computers, where many of us are watching this webinar right now, and even the sand on, let's say, a car's windshield is very hard to find. Now, you might say in the desert, sand is so plentiful, right? But the sand in the desert is very different from the sand that we use in all of our products. Desert sand is round, and that's why it can't stick together. But wet sand, which is found next to rivers, is very angular, and that's why it can stick together to form the different products we use. And there's lots of illegal sand mining happening because this river sand is very hard to find, and often the places where it is found are naturally protected parks, or they're just places where the government has banned people from mining, but illegally people are still mining that sand. So government has usually only two ways. Either the government is not aware of this, so they don't even know that illegal sand mining is happening, or just like as shown in this photo, they know that it's happening, and because the government in some developing countries is a little corrupt, they just move on. But that's wrong, because mining sand illegally disturbs ecosystems and ruins the environment. So that's why I wanted to create something to monitor this illegal sand mining, so that my device, Monsand, can be put close to the site, and using camera and sound, it can detect if sand mining machinery is operating or people are digging sand. So my solution, you guys can check out my video if you check out my Hackster post, but my solution is that I can take a photo of illegal sand mining, let's say with machines. I can detect the machines in the picture using YOLO V5 object detection. And taking an audio of illegal sand mining, I can use the sound to detect that machine sound is detected. And once I detect that, okay, illegal sand mining is happening, I use helium long range, helium LoRa, to send the data to Google Sheets, from where I send an SMS. To detect the machines, I trained a YOLO V5 object detector, and there was a very helpful tutorial in the C docs for that, which I followed and customized for my use case. And I can detect canoes, dump trucks, crane, excavators, and reloaders, which are all the different types of machines which are used in sand mining. And I can also detect a person, because in some like very poor countries, they don't even have machines to legally mine the sand. So instead they just dig it by hand, load it in canoes, and just send it out to wherever the sand is going to go. So I can object detect persons or canoes. And for the audio volume, I set a threshold. In this case, I set it at 600, and I said that basically if the audio volume is above that, I know that the machine is operating and machine sound is detected. For sending the data to Helium LoRa, I connect to a nearby Helium hotspot, and then I send the data to Helium. I've created a custom integration. I created a custom function to encode my data and send it to the Google Sheets integration. And then from Google Sheets, I've used the SMS extension so that whoever is monitoring this, whether that's an activist, environmental activist, or just a fellow hardware nerd who made this project, he can see that these were the number of machines detected, and this was the microphone value. And you can even see that I use the Sheets SMS extension to trigger a SMS to my iPhone whenever that illegal sand mining was detected. And for my future work, I want to show my sand truckload count for legal sand mining sites, and I'm looking to build a custom web application in addition to Google Sheets integration. Check out my GitHub and Hackster post, and yeah, that's my presentation.
Raunak, that was awesome. So there was a lot of technology in there, and a lot of terms that I thought it might be worth kind of unpacking. First of all, just the hardware. I know you used, I've got one here, handily enough. I know you used the wire terminal and the sense cap kit. Everything used was in this little jar, correct?
Yeah, I used the Seed LoRa module and the Seed Vision AI module connected to the wire terminal.
And so yeah, you mentioned the LoRa, and just because not everyone's familiar with all of these different technologies, can you just share a little bit about LoRa and Helium, perhaps?
So why I use LoRa is because in many of developing countries, like there's no, let's say there might not be Wi-Fi or like a very good connection. So that's why LoRa means long range communication. And basically it's technology that allows me to connect to a nearby Helium hotspot from which I can connect to the Helium cloud. And then that's where I can receive my data and then send it to Google Sheets or any other cloud service like Amazon or Google.
And for people who aren't familiar, Helium is like, you know, like you have AT&T and T-Mobile for cellular. Yeah. Helium is a provider like that for LoRa that's pretty ubiquitous in certain areas. The other big one probably being the Things network. So the machine learning aspect, you mentioned YOLO V5 object detection. Again, something that might be worth explaining a little bit just for the people that aren't familiar with machine learning.
Well, YOLO stands for you only look once, and basically it started out with the original YOLO made in the darknet framework, but the YOLO V5 I'm using is made in the PyTorch framework, which is basically a machine learning framework to build models. And basically there's different versions of YOLO which are different sizes. And because I'm running this on embedded devices, hence tiny machine learning, I use YOLO V5 small, which is basically a small version of the model. And I just train it on images of the different classes, let's say truck or canoe. So I give it an image of a truck or canoe that I've labeled as truck or canoe. And then the model gets trained on these different images. And when it sees a new image of, let's say, a truck, it can detect it.
Amazing. That's an astonishingly good explanation. Just a reminder, this is a 9th grader that we're talking to that is describing to us the intricacies of YOLO V5 and which particular type you should use for this application. Were there any other questions that came up in the Q&A?
There's one in the Q&A.
Don King says, very impressive. Are there any risks to you monitoring and reporting illegal activity to you as the
there is. There are sand mining mafias in these places, and some of them where they even kill government officials because they don't want to close their illegal sand mining operation. So this device doesn't have to be placed very close to the site. It can detect objects from far away. So you could put it, let's say, you could put it like a far distance away from the site, and then you could detect the truck. So if you just like put it inconspicuously so that they don't see it, you can just like put the device and be done with it. It can run on a portable battery. You can even connect the Y terminal to solar power, and that way you can have the device running forever. And by the time they even notice that the device is there, it's already too late, because the environmental activist or the government official has evidence right on their phone that they've been doing this.
That's really
fantastic. And I believe this was part of the Seed into the Wild contest, I think you said,
Yeah.
which the results are being announced today.
Yes, later
Pretty
on.
excited for the results.
Jessica has a question, says, how do you protect your published data collected so bad guys don't use it to their advantage?
Well, the data that I've made it so that the data will only go to whoever placed the device. And hopefully whoever's placing this device isn't corrupt. If the person who himself placed the device, like if you're a bad person, right, you won't place the device in the first place.
Right.
So the data is going through Helium, and then it's going to Google Sheets, and that's like a very secure pipeline, because like Helium we made its network very secure. It's actually right on their website that we have a secure LoRa network. And so that Helium itself is adding that security, and then it goes directly to Google Sheets in your iPhone. So bad guys can't change it really. If you're a bad guy, you're not gonna put the device.
Cool. Well, I think it's a good time to move on to our, thank you, by the way, that was awesome. A lot of people in the chat saying like, this is the first time that we've heard about this issue. And it's really cool to see that you've already got this amazing trained model, like being able to detect and differentiate between the 4 different types of machines. I think it's really cool.
Yeah.
But yeah, moving into the Q&A, I have a question that I wrote for Olya specifically, but I bet you other guys also have some interesting answers to this. Olya, I was reading an article about you, and it turned out that you had sourced your materials from really interesting places, like the parachutes and the infrared cameras specifically. And since it's a sustainability conference, I love the fact that you were using reclaiming some materials, as it were. I don't want to give it away, but I'd like to ask all of you, where you get your materials, if you think about sustainability in that, and Olya specifically. Let's start with you, because I think it's really interesting.
Yeah, there's definitely things that some things prove to be easier to reuse than others. But yeah, as far as in the Arctic capturing the bubbles, we bought on eBay like an old parachute, because it's really thin material, right? Folds up really well. We would, the idea was to build a rigid frame for the outside of it and then be able to capture it. The problem was, and it's like, they're incredibly well made, right? And obviously gas tight, right? Because they're parachutes. The problem with that turned out to be is that the shape was like quite wrong. Because of the flat top, you actually end up with so much lifting power, and there are no rocks in that area. So as far as like ballast to anchor things down, it's like a bring your own rock sort of situation. And getting into these remote sites is really tricky. And so there's only like so much that you can bring. So the parachute thing was like a good shot on goal, but we didn't end up using it. The methane camera was an auction of like an asteroid mining company going out of business, where we got this like amazing mid-wave infrared camera for like a tiny fraction of the cost of what we could have possibly gotten it. So that's kind of amazing. The other really fun one is that our mechanical engineer, Elizabeth Hillstrom, for any of you that know her, she's amazing. She figured out that a really cheap source of stainless steel that's already in like roughly the right configuration are kegs. And so our flares are actually, at least for a particular flow rate, right? Like, of course, it only comes in like one diameter, happen to be correct for one particular flow rate that is quite popular for the sources. And so kegs that are damaged to hold beer, for example, right? So like if the top and bottom is damaged, it doesn't matter because we cut it off. But the external thing is really high quality steel, super cheap if it's damaged, and yeah, like really great for what we need. And so Alaskan Brewing has donated some kegs to the cause that were like no longer good for their main usage.
That is so cool.
That is so cool. Should encourage other brewers to do the same. Pledge their
damaged kegs.
damaged kegs.
Yeah, Elizabeth in general uses a lot of kitchenware for fire because it's already rated for it. It's mass produced, super cheap, easy to reuse.
Cool. Other guests, any thoughts here?
Yeah, I have a question for Olya as well. There's been a lot of information coming in, so apologies if you explained this and I missed it, but I was just curious, you know, we live in, as much as we're talking about sustainability, we live in a capitalist society at the moment. And I was just curious, what is the business model for phosphomethane?
Carbon offsets. So essentially, because there is a market that, you know, compensates, basically gets a whole bunch of entrepreneurs to compete for who can mitigate climate change the cheapest, which I think is really awesome. They're not implemented perfectly, but the high level idea I think is pretty good. And so there's both voluntary markets and compliance markets. So in some jurisdictions like all of the EU, for example, there's sort of you know, companies have to either reduce their emissions or buy it from someone else that can reduce it from unregulated sources for some small percentage of their compliance. So we kind of play into that.
So when I click that little button that says offset my flight for $1.25 or whatever, it could be some phosphomethane that I'm doing.
It could be us. Yeah, we're not in the voluntary aviation markets yet, but one day.
That's really cool.
I had a good question in the Q&A, guys. If any, what parts of your projects are open source and how does that impact your project's progress?
I'm happy to talk about one of our projects. So our buoy itself is not open right now, but the bristlemouth protocol, so the protocol we're going to be using to communicate with below the water devices, that's going to be all open source. We're going to have example projects, development tools, that kind of stuff, because that's going to be more of a community use project. But as far as how does that impact the progress, I would say it just makes us document things even better, because, you know, if something's open source, especially as a company, you do have to make sure that it's up to par with, you know. But unfortunately, our main stuff is not open source. But
while we're talking about the bristlemouth, I was just curious, so it's a protocol. What is the backbone that, you know, for the protocol?
Yeah, so it's going to be the bristlemouth project. It's also going to include the physical layer and the physical device. So the actual wire, like the thickness, the gauge of the wire, it's going to be able to support the entire the entire buoy and all that stuff. So it's going to include the cable, the physical layer, so the actual modulation of the signal over the power line. And that's going to be using one of the new Ethernet standards. I forget the actual name of it, but it's a two-wire thing. And then on top of that, we're going to have a pub-sub, a publisher-subscribe model. So, you know, a user won't have to write all this networking code or anything like that, because you can have multiple devices. It can branch, all that stuff. So it'll auto-discover all that stuff. And then as a user, you can just publish, subscribe to data sources.
So I know we're nerds here, but just to take it back a step, it sounds like it's something that could be used as sort of a LoRa alternative, or it's in that kind of same space.
But it's wired, right? So
Right,
so this is only used between the the brains of the buoy and various sensors or devices, and so they can talk to each other. And then you can then use the buoy, like our buoy, or someone could make another one as a bridge to the internet. Yeah.
Cool. I was curious about other guest nerds' thoughts on the open source issue or on the materials. Anything you'd like to talk about that we didn't cover already?
Well, all of my projects are open source because I post on Hackster and
Yeah.
actively on GitHub. And that helps other people see my projects. And I love getting like different types of feedback. And I love to think about like how I can improve my project further. And regarding the materials, even though I have access to the 3D printer and I actually learned CAD over the summer, Inventor and Fusion, I don't stick to 3D printing. Even for my project, if you see, I just heat it up all together because the PLA plastic that we use in the end, it will just go into a waste stand. So the best thing to do usually is that as posting on a Hackster, I've seen that my audience really wants to see like the internals, how it was built, and just like the raw product. So I usually, instead of boxing it, I just like put it all together using tape or some homemade materials, and then I just like show it that this is my product. And I just don't try to use like the microchips in this, like the kit I got from Seed. It's not totally like sustainable, like some metals and microchips also use, but I can try my best to not use unsustainable material.
Nice.
Yeah, I guess I'll comment on our stuff. You've noticed this is plastic, so we are very much aware of that, and we're doing our best. We're offsetting through. It's similar to the carbon offsets. There's a thing called Plastic Bank where they remove plastic from the ocean. We recover most of the drift into kind of shores. We have a rewards program, if you will. So if somebody finds them, we get them to ship them back to us, and then we redeploy them. And far out, but we are starting to investigate making the hull out of biodegradable materials. That's a much kind of longer term project, but it is something we're working on.
That's super cool. I put a link to Plastic Bank in the chat. There's a related question we have from Konstantin, who says, can a whale accidentally swallow a buoy?
I don't know, to be honest. I guess they're small enough, but they would have to go searching for it.
So
yeah,
can they intentionally swallow a buoy?
I mean, I guess if they wanted, they could. I don't know if that's ever happened. They're kind of like, I feel like whales eat small fish, right? Not like, I don't know.
Well, but if they just open their mouth, it might just, flow in.
I guess, yeah.
I guess you'd know if it suddenly starts reporting super weird, like super high pressure data, like.
Well, I wouldn't be able to communicate through the whale probably, but.
Right.
Yeah, I don't know if it become a IoT device for within whale kind of can.
IoT
all of a sudden become a like an animal monitoring
out there. Make it taste bad. Very good.
Somebody also did ask about the communications. I think you kind of covered that talking about Starlink. Is that right?
Not Starlink, but Iridium.
Cool.
Yeah, so we're using Iridium, which is a satellite constellation that's been around for a couple decades, and then cellular. We have looked at other satellite constellations. So there's Swarm, which was acquired by SpaceX, but it's a lower bandwidth, much lower cost. Because Starlink, you need a very fancy antenna to use for right now. In the future that might change. But well, I guess the light's off. But yeah, I didn't move enough.
Somebody asked about the cost of the communication.
It is very expensive. The satellite connectivity is extremely expensive. So we send the data we do bit packing basically, right? So if a measurement takes 12 bits, we're not going to send 2 bytes. We're going to send 12 bits, and then we pack everything. Once we're using cellular, then we can send tons of data, and it's a lot, like 100 times cheaper per byte, if you will. But yeah, satellite communications are not very cheap.
We have another question for everyone. What's next for your work? Scaling, deployment, getting it to people who need and will use it. I was also curious about how, how individuals who are interested in this could get involved. Like, could they hook you up with, funding, with introductions to specific types of people, with volunteering, with, research in specific areas? Yeah. So what's next, and how can people jump in? I guess we haven't heard from you in a while. Yeah.
Yeah. Oh my God, tons of ways. We are still a very small team, and so when you're tiny, there's just so many more things to do than time. So there's a million different things. If there are any methane sources, like your uncle lives in an area where there's an old landfill, or we do get reports of like methane coming out of people's water wells. There's like a bunch of stuff like that with like a variety of methane sources. You sometimes don't even know what caused it. But if you're in an area where you're aware of methane, or then definitely let us know. We are interested in many methane sources, even if you can't like attribute it. Regarding funding, all startups always need funding and awards and all sorts of stuff like that. So we're never going to say no to that. And then, you know, we do have a lot of technical problems that we could always use more firepower on. That gets a little bit trickier because there is a lot of work that has already been done in lots of contexts. So that's the kind of thing where it's easier when people have like a little bit longer time to dedicate. And then there's like general research, like literature, Googling kind of thing about a whole bunch of ideas that we have that like have absolutely no time to implement. So if people just love general research, there's lots and lots of stuff on that too. And I'm just Olya at frostmethane.com. So yeah.
Yeah, and Olya, you have this diamond list, right? Now you are the founder of.
Mm-hmm. Yeah. Yeah. That one is like a very basically there are, you know, as we kind of did our fundraising a couple of years ago, you know, you discover very quickly that climate change is the size of like the entire economy, or sustainability, right? Like every time you talk to someone, you find out about a new cool problem that you didn't know was a problem, and they have some cool solution to it. And so, you know, as an investors can't necessarily be experts in everything, right? And so often they talk to these really awesome teams and they're like, wow, these are great, but they can't invest in them, right? Like sometimes the investor themselves don't have the expertise. Sometimes their partners or the people that gave money to the investment firm, like they have certain criteria. And so this is just a way of surfacing really good early stage companies that, like, you know, because there's like hundreds of investors in the space, right? If you're just trying to get investment and you're just talking to all of these 200, like that's your entire year, right? Like you're not necessarily making that much extra progress. So having these people sort of do kind of collective due diligence on it, right? And basically be able to surface it so that somebody's like, oh my God, here's a hydrogen company. I'm super interested in hydrogen. Flows up. So once a year, we basically send out like an Airtable form and get everybody to float it up. And that's been actually really, really good as far as getting these really early stage, like less than 5 million raised startups, both resources, some media attention, and there was like some set of volunteers that were using the list as like, hey, these companies are so small that if you've got skills, like smaller companies are, you know, pretty hungry for a little bit of extra skill. So I think that was, we're pretty happy with the impact that it ended up having, even though the idea is like very, very simple. It is modeled after Hollywood's Blacklist. That one is very long running. And so that has, you know, a much better tracking of its impact over like the 10 or 12 years that it's been around.
Wow. Cool.
Mandeep Singh had a couple questions for Álvaro. Specifically, is the code that you're running, is it ROS? Is it just C code? What is running on the?
Yeah, it's a mix of C and C++. Basically, we're running FreeRTOS, so it's the real-time operating system. I believe Bristlemout's all going to be software based though, but still, it's just it's pretty standard.
Cool. Álvaro, what's next for your project, and what are you looking for from people who might be watching this?
So we just released the cellular version of this. So now customers are going to be able to get almost near real-time wave information and all that stuff. So we're able to do a lot more measurements and things for customers for nearshore applications, right? Like the ones in the open ocean are still very bandwidth limited. And so next year is mostly going to be focusing on Bristlemouth. So we're going to get the first version out, get their development kit out, and start developing different sensors and things to attach to these buoys.
Exciting.
Mm-hmm.
For me, as a ninth grader, I can't say I aspire to make my own startup too, as my amazing co-guest. But for now, I just plan to just to learn more skills. So one day I can also take my prototypes right now to to become a real company and hope I make a real impact.
Awesome. Cool. Well, I'm going to see if we can open this up for everyone.
Well, when that time comes for you, if you'd like if you'd like to learn from the mistakes that I made when starting a company, I will, if I can help in any way, definitely reach out.
Yeah, get Olya's info, start connecting now.
Cool. We're looking to transition into the next part of our of our session here. Usually we try to open this up so that everyone can join and like turn on your video and talk to each other and ask questions and stuff. But I think we might be having some issues with that. So my co-hosts, if you have any expertise there, would be helpful. And in the meantime, we're wondering if you panelists have any questions for each other. We've got more questions, don't worry, but like, yeah.
Did you want me to just let people talk from the audience?
I think if we bring everyone on the video, right? Do we just promote everyone?
Audio and or video for everybody.
Okay, I can let everybody talk. I'll just go down the list and have everybody allowed to talk. And if you guys want to open up and talk, you can go ahead and do that. So I'll go start.
And in the meantime, I want to ask Álvaro a question, which is, what's the coolest thing you've learned while kind of working on this ocean project? And it could be a technical thing. It could be like fun fact about a fish. Like I'll take anything. Oceans are the reason that I'm working on climate change, even though I'm not working on.
I mean, that's most of us here. Oh man, I've learned so much about about waves, about ships, about animals. So this is one of our shirts. That, and this thing is called a pluteus, and that's kind of it's a larval stage of a sea urchin and like starfish and stuff, and that was one of the code names for a previous project. So I've learned just by code names, this new project's internal code name Sunflower, and that's the sunflower starfish. So I've learned a lot about ocean, just ocean things. Bristlemouth, the bristlemouth project, that's a type of fish. That's one of the most, I don't know if it's the most common vertebrate on the planet. It's one of those things that you just learn all these really cool things about the ocean.
Awesome.
Yeah.
Wow, the most common.
You mentioned in your presentation real quick about like methane in the oceans, like methane hydrides are like a big open question on whether that's like a feedback loop we should worry about or whether they're reasonably stable. So I think that there's like, it's a reasonably recent area of research, but I think there's like lots of cool stuff around that, but it is only in very specific areas.
Well, and that's the thing, right? We don't know most of what's going on in the ocean. Like we have satellite satellites measuring ocean weather, but you can only get the surface of the water, right? You don't know what's happening right below. Also, the resolution is not great. And we don't have a methane sensor right now, but if there is such a thing, we could put them in the buoys and then we'll know methane labels in the middle of the ocean, right? Like, which maybe that there's nothing, but we don't know.
Yeah, well, we definitely, we know a little bit about methane hydrates. I think there's like huge open questions. Like the place where that would be like immediately useful, even if it doesn't perfectly station keep, is there's questions about what's happening with the permafrost in the northern oceans. So I think there are areas where for sure that there's methane. It's kind of a question of like how much and like winter to summer, blah, blah, blah. So I think there is like tons of interesting data there that like it would be fantastic to have one day.
Yeah, no, and these buoys, like we have some on the Great Lakes, they use them for measuring tides, one of the sensors we do have is turbidity sensor. So it measures how much sediment is in the water. And they'll use that near dredging projects when they're kind of scraping the bottom. And if the turbidity goes too high, they have to halt the project. So there's a lot of like, what's so exciting about Bristlemouth is anyone who has all these cool ideas about sensors can now just build a sensor without worrying about the rest of the infrastructure. And we'll be able to, do a lot more science.
Rad, do we have a question from Manju?
Yeah, Manju is raising his hand. Yeah, Manju, feel free to unmute yourself and ask question.
Or just chime in with your own thoughts on these questions.
Yeah.
It is open season.
And
I'm gonna promote you. Oh, they're gone.
Okay. But I do see Travis here. And if Travis, you're here, Rasheen talked about helium. And Travis, is from the helium team. I'm putting him on the spot here, but we'd love to see what you think of his project. Is he gonna come on? Maybe he's not here. Anyone from the helium team? No?
Travis is on here. Let's see if we can get him on.
Yeah.
And in the meantime, we have a question from Eddie, who says, how can we get involved in the methane monitoring or any of the other projects? Personally, I think, Olya, you gave us your email address, which is olya@frostmethane.com. Is that right?
Yeah, that's right. It very much depends on what the skill set is. And there's, I'm happy to be self-serving and say how it like can help us, but there's also other methane projects. So if you email me with like skill sets, how much time you have to dedicate, like what kind of things you're interested in, I can help direct to either us or other people that might be a better fit. But there's lots of both academic and private industry and nonprofit projects around methane. It's as of like a year, maybe 2 years ago, it like became a much hotter topic that it used to be when we started this, where all of our pitches started with, let me tell you what methane is.
Yeah, and now it's more like if people sort of generally know what the deal is.
Yeah. Now it's you get to the point of our innovation a lot faster compared to what it used to be, where like you really needed to set the stage and have a lot of context and have many more conversations before you could kind of get to the meat of what we're doing differently. So this is fantastic, right? Nice. The more context, shared context, the better.
Oh, you have a question about your startup. So most traditional startups, I think, are trying to foster explosive growth so they can have a high value exit. Is your startup's best exit to make yourselves obsolete because there's no more methane, or is that not how it works?
Well, the sources that we tackle are typically continuous. So we will at least have a maintenance thing for a really long time. But if in 100 years we're obsolete, I think that's kind of a great outcome for everybody. But I suspect that it's going to be lots of like, we track down all these sources, hopefully in some reasonable number of years, we can install on a lot of them. And then I would say any company that's like a one-trick pony usually doesn't survive forever. And whether it's us or like I'm sure that even Google is worried about that, right? Like how long is search going to be relevant? Maybe a long time, maybe not, right? Maybe better stuff comes up. So I think we'll, I would love it if we were obsolete on the methane front. I think that would be just fantastic success. I can die happy.
I have a question for everyone around communication. So when we were putting this together, even when we were making a little promo video, we had this question of like, do we start out with statistics showing how dire the situation is because that sort of prompts urgency? Or do we say everyone kind of knows that it's urgent, that we're going to be talking to, and should we focus on hope? And when you folks are talking to other people about the climate and your work, what kind of an approach do you take? Do you focus on urgency, hope, other things? Like, yeah, what do you find most effective?
You want to go ahead, Olya?
Sure. So I think different things work for different people, right? I think some of the journalists have gone a little overboard on the like disaster things, right? Like to the point, like I think it's what worked for me, right? Like I lived in Canada, I'm originally from Russia, and I'm like, global warming sounds great. I would like it to be warmer. Fantastic, right? And it was a 4-page article about ocean acidification, actually, in Scientific American, that made me go from like, global warming sounds great, to like, oh my God, I'm not working on, like, this is the thing I'm going to be working on forever. Right? And that article wasn't alarmist, right? There wasn't like, all it said was, hey, here's this particular, the oceans are becoming, less basic, and here's how it could potentially affect the marine chain. And they're not saying, for sure, we're going to get a mass extinction. They're just saying, here's this chance, not a double-digit percentage chance of this catastrophic event happen. And I'm like, look, I'm just not okay with this, right? I am not okay with us having this situation. And so I didn't need any absolutism. Like for me, the statistics of a particular thing I cared about like really worked. But for other people, it doesn't. I am personally the kind of person that really likes focusing on solutions. But that's like, that doesn't mean that it's effective for other people. It just means that that's the most true representation of how I think about it. So for me, I will focus, like, let's say 20% on the problem, usually not in absolute terms, usually with like, hey, there's like 20% chance of this, right? Like, even though we tackle something that could potentially be a runaway feedback loop, I don't think the chances of that are really high. It's just the impact is, right? So yeah, so basically I will spend a little bit of time talking about the problem and a lot of time talking about the various solutions that will allow us to keep all of the benefits of modern civilizations with reducing the harm to the environment.
Nice. I really like that contrast between the global warming, which does sound kind of like warm and fuzzy. And if it's winter, you're kind of like, can we get some of that? And you hear that a lot in, people, some segments of society's responses to this, like trying to say it doesn't happen. But like, if it did, wouldn't that be nice? Compared to like language, like ocean acidification, which doesn't really sound nice at all.
Yeah. Yeah. It's just like, it's a big experiment, right? And I think it's fine to have the debate of like, is it better if things got a little warmer, right? Like, I think the answer is no, now that I know enough about it, right? But like, having that conversation isn't a bad thing.
True.
Raunak, I actually have a question for you. And, like, although you're a ninth grader, of course, getting through school is like your priority, but, with this kind of early idea that you have already built out a prototype and you have like people like Olya and Álvaro here, that's people who have gone through that technology commercialization journey, right? What's kind of your questions, to them? What advice will you seek from them, when you are thinking of, if I'm going to do this as a startup and I'm going to keep building this out, and the kind of mentorship or advice you'd want to get?
My main question would be like, once you had your basic prototype of your like idea, like your first prototype, what were your steps into like developing that into an actual product?
I can speak to that a little bit, unless gone through that probably a little more recently than so far.
Todas las charlas hasta que llegaste y después no pude ver nada. Y jodés con el gorrito.
We did get people on. Yay, the tech is working.
Fantastic. Okay, so I think the first question is, who's going to pay for this, right? Because fundamentally, you just like, it sucks, but you need resources. And the answer could be like, not just like startup is not necessarily always the right answer, right? It is entirely possible that you want this to be a nonprofit, right? Where there is enough people that care about it in a variety of ways that you might be able to do that. And the answer could be, governments, it could be private industry, it could be like the local community. So lots of folks, but the question is kind of like, how does it get out there? And usually where does the money come from is, for better or worse, is part of how the question of how it gets out there. So we thought a lot about whether we want to be a for-profit or a nonprofit. And we thought that our unit economics were good enough and that we could be a for-profit and we would have easier access to capital to develop our product by being a for-profit. But I could imagine a scenario where that wouldn't be true. Right. And that's cool, right? Plenty of extremely impactful nonprofits that are like absolutely respect. So I think there's lots of ways of getting this stuff done. And as a nonprofit, you can still earn revenue, right? Like you can still have these customers. It basically just means like people donate money in addition to whatever your revenue model is. And there are some nonprofits that are actually profitable from that, like certain years, but maybe not other years. And they can fundraise for like programs and like other kind of value streams, right? So the first thing that I would do is kind of figure this out, like who will be getting it out there, who will be maintaining it, who will be, and maybe that's people you hire, right? And maybe it's kind of your customers, right? But sort of figure that out of like just how it gets out there, and then start talking to those people like as soon as you can, right? Because maybe they're like, oh, like this is really great, but actually we'd also love to I don't know, zoom in on people on the license plates of any cars together, right? Like, so you kind of get like a lot of like feature requests essentially, and then get it out there as soon as possible, even if it's like for free, even if it's like, like in my case, I had a reasonable engineering job before that. So like I had, used my bank account to like help things get out there like a little bit at first. To just kind of make sure, hey, if I'm going to really sink a lot of years into it, is this going to be the right thing? Lots of grants out there for both nonprofits and for-profits. I should have started applying for them sooner rather than draining my bank account. So I 100% regret that. In the US, the SBIRs, NSF SBIR is one of these things that's like really great, like super underrated. And then at some point, once you're kind of like feeling strongly enough that you're willing to spend your next couple of years on this, and that you think there's kind of an impact, then I would say getting a team together, and then starting to like fundraise, whether for profit or nonprofit, to get it out there more than just like 1 or 2 experiments, really like get 10, 20 out there, and sort of see how well that works. That's kind of, I think, how I would go about it. Some of those steps are more fun than others.
Yeah.
So yeah, I saw a quick question. So when you got like your first prototype running, did you like figure out how you wanted to improve it first, or did you like deploy it in a real environment and then say, oh, what are the changes we need to make? I know you hinted at it in your presentation, but
yeah, deploy it as soon as possible, because it's
that's what I was trying to do.
Yeah, no, that would be amazing. And I love, you know, I really like your sand approach. I think it's a really unique problem. Yeah, it would be fun to brainstorm about like what's I mean, I'm sure you've already thought of a lot of things of how to like actually get it out there. And if at some point it's like a few $1,000s that are required, then that's something that we could fundraise for, right? Like fundraise, like friend fundraise, not like investor fundraise for.
Yeah.
Yeah, and just add on to what Olya was saying. So even in today's our early panel, somewhat of the early version, and today to talk about grants, you know, that's impact specific, you know, even off from the UN side. And also just want to also put a plug in and for today's later demo session, Ribbon Network. Ribbon Network's founder, Keenan, he will be doing a demo on his CO2 sensors, IoT, and he's doing it totally nonprofit way. So please join that session if you also want to learn, you know, a kind of like a different approach, but there are just so many citizen science and climate tech innovators out there that's approaching this in different ways that you can have get advice from, and this is why we love our community.
Yep, thank you.
Are there any like databases of this type of grants? I saw that you mentioned the SBIR grants, and I dropped a link to that in the chat for anyone who's interested in checking it out. For people who are watching later, we'll put it in the description of the video. And yeah, is there anywhere that you can go to find like a centralized list of other things that are like that? What would you have found?
Yeah, I know that there's like there's a service, Joel, I'll remember his last name. I hope I can email it later. But there's like folks that are kind of specialized in this in the US for like government grants, right? Like that help. Like ARPA-E is a really big one in the energy space in the US, where I'm very because we're based here, I sort of know the context here a little bit better than in other places. Lots of philanthropies. I think there are some like Googleable databases. Some philanthropies are much more transparent about how they do their grants than others. I also know that like USAID or other kind of development grants are sometimes really helpful if you're interested in developing world technologies, you know, often around agriculture or water or access to clean energy. Those are ones that sort of jump to mind, but as well as a really great database, I'm not sure that I'm aware of one, but those are the ones like, you know, of course in health, like the NIH, like that SBIR, like NSF is like one thing that applies to SBIRs, but almost every, you know, like NIH has like a medical version of SBIR, ARPA-E has an energy version of an SBIR, and I believe there's another couple of agencies that have that as well. So almost all of them, and it's a super, I don't know, we're part of the ARPA-E SBIR, and it's fantastic.
Cool. So we've got about 6 minutes left. I personally, unfortunately, have to drop off and go help start our next session, but it's been so lovely hanging out with all you nerds. Thank you everyone who joined, and I'll let my co-host take us home. Thanks.
Yes.
Everyone.
Yeah, we'll say bye to Alex, but we will be keep going on here until like 1:30. Any other questions from the audience? You can totally unmute yourself. You can come on video if you feel like you can talk. This is the kind of interactive session, you know, of our summit. And
there was a lingering Q&A question. It says literally, why is swam not an option? But I think it means swarmed.
Yeah, I think that's for me. Yeah, so Swarm is a different satellite constellation. It's an option. It's just we don't have the engineering resources and time to do all the things. We chose to prioritize cellular connectivity first. So to integrate Swarm, we do have Swarm modems, but it's a different antenna setup, different drivers, all that stuff. So it's mostly time and priorities, but it's definitely an option.
Another question just came up for Hackster team. When will they announce the winners? I think that's referring to the seed contest.
Yeah, it's this afternoon. If you look at the agenda, or if you look in your Zoom event, today at 2:15 p.m. Pacific.
It's about 45 minutes from now.
Yep, 45 minutes from now. So there will be a Microsoft workshop between now and the winner announcement. If you would like to join that one's actually also on Azure RTOS. If anyone's interested in that, also has Seed integrated with Seed, with Arduino. So a lot of you nerds probably will be really liking that workshop as well.
I have a question. So today at the magazine, it's our last day to get everything to the printer. So I haven't been able to be part of the summit very much. But I'm just curious, just very high level, what resources anyone in the room and our guests and anybody can share in terms of learning more about this stuff. I picked up a book recently called Less is More, which is, well, I haven't read the whole thing yet, but it kind of opens with a lot of the doom and gloom stuff that we were talking about, but kind of, I wasn't aware of. I mean, global warming, I feel like I've heard about my whole life, but some of the topics in there, like what's happening with soil, like apparently by 60 years or 2060, like soil will be pretty much useless around most of the world, and you won't be able to grow anything anymore unless they start doing things differently. So I'm learning a lot of things from this book, and I just wonder what other resources our guests or anybody in the audience, anybody recommends to learn more about some of the topics we're discussing at large today.
And where is everybody from? Where are you tuning in from? If you can put it in the chat, or come on screen if you feel like. But I definitely, in general, from like even our Discord, I think people from around the world really joined here today. And definitely, I think impact and sustainability is a global problem. So we're really happy, to have this global community to share all these stories with us. New Jersey, Texas, Denver, Italy, Germany, Houston,
I can
Denmark.
Quickly answer the resources thing. There's some really active climate Slack communities that I think are great. So Work on Climate is a really good one for engineers. My Climate Journey is a little bit more business rather than engineering, but they're both really good complements to each other. And they have their own event series and podcasts and that kind of stuff. Climate Base is like if you're like practically looking for a job, that's a really good one. There's a book called Project Drawdown that has like kind of like goes through some of the issues in like a reasonably visual way. I slightly disagree with them on their nuclear analysis, but short of the nitpicking, it like is pretty good on kind of a wide variety of the major issues and solution points. And seriously, like the way that I learned about this is like a lot of local meetups. Like there's in almost every city that I know of, there's a bunch of meetups with a lot of people that are like sharing their experiences about the various bits and pieces, and sometimes it's electricity, and sometimes it's farming, and sometimes it's transportation. But I think all of that stuff is like learning from. I'm a computer scientist, but I'm actually a very like in-person person, and so I would say just collaborating locally, physically with other people is really fun for me. So that's kind of how I originally learned like 10 years ago.
Awesome.
Yeah.
I love that answer. Thank you.
Yeah. And oh yeah, where are you based out again?
I'm in San Francisco, though the company is in Juneau, Alaska.
Yeah. And so in San Francisco, is there any special space that you go to and meet up?
Sorry. Oh, for meetups for the climate. So stuff hasn't quite recovered post-pandemic, but pre-pandemic there was Data Sciences for Sustainability that was super good. eDiscuss. Climate Link, Powerhouse used to have events at least every month. They still have a big party. Diamond List occasionally has a party that like we throw once a year. So there's definitely like a lot of that. A lot of that stuff, some has recovered, some hasn't quite recovered. Once in a while, I throw like a lecture series on kind of various aspects of climate. But I unfortunately have to hop to my 1:30. So
Thank
thank you so
Yeah,
much for
thank you
having me.
so much.
Wonderful
Yeah.
to meet you and the other speakers with your amazing projects. Yeah, maybe catch up in San Francisco.
Yeah.
Yes. Thank you
See you
so much,
around.
Olya. And thank you everybody for your time. I did throw a link for our topic channel on sustainability on Hackster. You can continue if you have any other thoughts, comments, join that channel. And there's also a discussion tab where you can pop in and interact with other people from around the world and continue on with this conversation. But thank you so much. And I will see you in other sessions.